I asked you guys to grab it when you came in. It's your two stapled pieces of paper up front. They are not hole punched because Mr. Turner's hole puncher is broken, like the computer in his room. All right. So today we're going to talk about creating polynomial equations written in factored form. So we might have to do some things that you learned in Math 1 and definitely Math 2 to be able to put equations in standard form. So the first thing I want to tell you is that the roots or the zeros, wherever the graph crosses the x-axis, when I look at a polynomial equation written in factored form, notice that my roots are right here. This is R1 and R2 and however many roots I have, okay? So, for example, if I had a root, if I cross the x-axis at -4 and I cross the x-axis at +4, I would write my equation in factored form as y equals a times the quantity x. What is x minus a negative? What is x minus a negative? Do we write that? Yeah, we write it as x plus 4. And then my second root, x minus 4. Okay? Does that make sense? That's all we're doing today. Okay? Well, not all of it, but kind of. So we're going to be given an equation. So our example number 1, and we're going to do some sketching. Example number 1 says, determine the equation of the quadratic function. So it's quadratic. That means my graph looks like what? A U. It's either going to go up or, okay. So given the quadratic function, whose roots are -3 and 4. So if the roots equal -3 and +4, what are the factors? Yes. Just needs plugged in. Shh. What are the factors? Shh. If the roots are -3 and +4, what are the factors? We write factors as x something, right? Yeah, the factors are x plus 3 and x minus 4. Okay, x plus 3 and x minus 4. Well, I know something else about this. I know it passes through the point. It passes through the point or the ordered pair to -50. So here's what we have to do. We have to make sure, like we have to calculate for a. So we're going to try to write it in factored form and solve for a. So we're going to use this function, y equals a times, let's see, what are my factors? X plus 3 and x minus 4. And we have to solve for a. We have to figure out what that multiplier outside is. But we have 3 variables. We have y's, a's, and x's. But do we know a specific x and y that our graph passes through? It says right up there, point. What? Yeah, to -50. This is the x, and this is the y. Are you following along? Okay, let's do that. So y, -50, equals a times what is x? 2. 2 plus 3. Times what is x? 2. 2 minus 4. Okay, so we're solving for a. Let's see, -50 equals a times, what is 2 plus 3? And what is 2 minus 4? What is 5 times -2? So -50 equals -10a. Does that make sense? All we did is took the ordered pair, plugged it in for x and y because we're trying to solve for a. We need to figure out what the multiplier is, okay? How am I going to get a all by itself? Divide both sides by -10. Divide both sides by -10. So 5 equals a. Okay. So I know that a is 5. I want to I want to figure out what my equation is going to be in standard form, and I know that I have two factors. So we can either FOIL or we can use the box method. How many of you guys like to FOIL? Yeah, if you like to FOIL, FOIL. If you like drawing the box, draw the box. So let's see. X times X is X squared. X times 3 is negative 4 times X is, and negative 4 times 3 is. Remember that when you use the box method, typically, not always, but typically, the terms on the diagonal can be combined. So this actually ends up being X squared minus 1X minus 12. But remember, we have a multiplier of what outside of it? We have a multiplier of 5 outside of it. So we're trying to put it in standard form, so we have to multiply all the way through. So let's see. That means y equals 5 times x squared is 5x squared. 5 times negative 1 is negative 5x. And 5 times negative 12 is, okay. We have to sketch a graph of this function. We have to sketch a graph of this function. So here's what I know. I know 2 x-intercepts. Negative 3 and 4. I know the y-intercept, which is what? I'm going to rewrite this as 2 x-intercepts. What is my y-intercept? Think about what you learned last year or in Math 1. ax squared plus bx plus c of a quadratic function. What is the y-intercept? It's c. So the y-intercept happens at the order pair 0, negative 60. And then we also just know some random point, right? Our random point is 2, negative 50. So we have 4 points that we can use to graph a pretty nice looking function. Let's see. I cross the x-axis at negative 3. 1, 2, negative 3. I'm going to plot a point. That's my first root. I also cross... sorry. It erased and then I lost my spot. Negative 1, 2, 3. I also cross at positive 4. 1, 2, 3, 4. Let's see. I cross the y-axis at 0, negative 60. So I'm going to kind of split this in half because I know this is negative 100. So I'm going to say negative 50 is right here. So I'm going to say that 0, negative 60 is this point right here. Are you guys okay with that? And then I also pass through the point positive 2, negative 50. It's funny how the point positive 2, negative 50 is 2 units away from the left side of the root. So if I go 2 units away from the other root, I know that it also crosses at negative 1. Like it also has an order pair at negative 1, negative 50. Why do I know that? Yeah, same distance from the middle. These are symmetrical. These points are like your quadratic function is symmetrical, right? So the only thing I don't know is my vertex, but that's okay. I think that we can still sketch a nice parabola. I love it. That's fabulous. So this is the order pair 2, negative 50. How do we feel about that? Golden. Okay, and here is our equation in standard form, because that's what it wanted us to come up with, an equation in standard form. Okay. It is important to understand how the a value affects the graph of a polynomial. This is easiest to explore if the polynomial remains in factored form. Consider the quadratic polynomial, so here's another quadratic polynomial, of the form y equals a times the quantity x plus 2 times the quantity x minus 5. And it tells us that a does not equal 0, right? So what are the x-intercepts of this parabola? Oh, go ahead. Say it again. Yeah, the roots are -2 and +5. Okay, the roots are -2 and +5. Because remember, the roots are they have the opposite sign of the factor. Okay, so we have to sketch on the axes all three of these equations. So we're going to graph three parabolas. So if you want to use three different colors, please do. So my roots don't change. I'm crossing at -2 and +1, 2, 3, 4, 5. And if I were to FOIL this out, what is the y-intercept of this function? Of the first one? What is 2 times -5? It's -10. So this actually crosses the y-axis at -10. So this might look something like this. That's his first function. Let's look at the second function. Still has the same roots. It's still crossing the x-axis at -2 and +5. However, when I FOIL this out, let's see, 2 times -5 we know is -10, times 2 more is my y-intercept becomes what? -20. So now I don't cross, I cross the y-axis at -20. So I'm putting a stretch, right? I'm putting a vertical stretch on my graph. So it's getting stretched. Well, what about this one? Can we figure out the y-intercept of the last function? Y equals 4 times the quantity x plus 2 times the quantity x minus 5. Where do I cross the y-axis? Well, 2 times -5 is -10, times 4 is, yeah, -40. So still going through the same roots. The roots don't change, but now I'm crossing the y-axis here. So I'm putting this great big stretch on my parabola. How do we feel about that? Max, do you feel okay with that? Are you awake? Okay, good. Then get a color, get different colors. You have the graphs already for you. Just color over them. Alrighty. As we can see from this exercise, the value of a does not change the zeros of the function. It only changes the y-intercept. Where is my water bottle? Oh, you're so awesome, Kane. I did. It was in the top room. Okay. All right. But it does change the vertices and the y-intercepts. We can create equations of higher powered polynomials in a similar fashion. Sorry. So now we're going to deal with a cubic. Cubic means that it has 3 roots, right? So create the equation of the cubic in standard form that has x-intercepts of, so I'm just going to write down what the roots are. So my roots are -4, +2, and 5. That means that my factors are x plus 4, x minus 2, and x minus 5. Good job. Okay. We also know that our function passes through the point 620. This is going to help us figure out our value of a, right? Because that's going to be the x and the y that we plug in. Alrighty. So the first thing that we need to do is start like either foiling or figuring out what this is going to look like in standard form. But actually that's not true. Let's figure out what a is first. How am I going to figure out what a is? Someone tell me. Y equals a times x minus r x minus r, x minus r. That's like the parent function, 1, 2, and 3. What are we plugging in for that? Do we know what our factors are? Do we know some things about x and y? A, what do we know? Someone tell me. What is y? Y is 20 equals a times, what is x? And what is our first root? So minus a negative 4 becomes plus 4. We're just using our factors, right? And then I have 6 minus 2. And then I have 6 minus 5. All right. What is 6 plus 4? And what is 6 minus 2? And what is 6 minus 5? 1, right? So I really have 20 equals, what is 10 times 4? 20 equals 40a. What do you want to do now to get a all by itself? Divide both sides by 40. So a equals 1/2. All right, that's cool. But we still have to put this in standard form to figure out some things about like our y-intercept and stuff. So can we FOIL the first two and then do like a 2 by 3 box for the last one? Just say yes. So I'm going to take the last two factors and I'm going to use FOIL. So let's see. X times x is x squared. X times negative 5 is negative 5x. Negative 2 times x is, and negative 2 times negative 5 is, when I combine like terms, I have x squared minus 7x plus 10. I have to throw the other factor in here, right? So I can figure out what the cubic function is going to be. So I'm going to multiply this by x plus 4. So x times x is, or sorry, x times x squared is x cubed. X times negative 7x is, x times 10 is, 4 times x squared is, 4 times negative 7x is negative 28x, right? And 4 times 10 is, remember we always want to look at the terms on the diagonal. So I end up with x cubed minus 3x squared minus 18x plus 40. But all of this is getting multiplied by a, which is what? 1/2. Okay. So y equals half times x cubed is 1/2 x cubed. Half of negative 3 is, well, that's just negative 3/2 x squared. Half of negative 18 is negative 9, so that's negative 9x. And half of 40 is 20. So here's what I know. I know that I cross the x-axis, because we have to still graph it, at negative 4, 2, and 5. I know that I pass through the point 620, and I know that I have a y-intercept of 0.20. So we have 5 points that we can use to graph this function. 5 points. I'm going to start with my roots. So let's see, negative 1, 2, 3, 4. I want this to be in red. Negative 1, 2, 3, 4. And then I have the root positive 2. And I have the root positive 3, 4, 5. I cross my x-axis at, or I cross my y-axis at positive 20. So 50, and I'm going to break this up, 10, 20, 30, 40. So right here is where I'm crossing the y-axis at positive 20. And I know that I also pass through the point 620. Okay. What's my end behavior going to do? Let's see. It's degree 3, and my leading coefficient is positive. Look at your chart from yesterday. Degree 3, my leading coefficient is positive. So that'll tell us which way our tail needs to go. So odd, positive. Look at your chart from yesterday. Odd, positive. I'm not telling you. You need to look at your chart from yesterday. Odd, positive. Tell me what happens as x gets really small. As x approaches negative infinity, what does y do? Look in the odd positive box. Odd positive. Say again. They do go up and down, but I want you to look specifically in the odd positive box. Specifically in your odd positive box. Right here. So positive, odd. I'm looking right here at this last one. See it? Top row, last one. What does it say? As x approaches negative infinity, what does y do? Approaches negative infinity. That means as x gets really small, my tail goes down. So I know that this is going to go like this. I have to know that. I have to know which direction my tails are going. We know that it's cubic, so it's going to go in opposite directions. So let's just start kind of hooking these pieces together. There we go. You have to know something about your end behavior to figure out which way your tails are going. Okay? You have to know something about your end behavior. So when it's odd positive, we said as x approaches negative infinity, y approaches negative infinity. That tells us enough information because we know that odd degrees go in opposite directions. So if one is going down, the other one has to be going up. Alrighty, let's look at example number 4. So create the equation of a cubic in standard form that has a double zero at -2. So when I think about my x-intercepts, and I have a double zero, or sometimes it's written as this, multiplicity. You might see it like this, multiplicity. Nice if I could spell that. That just means that if the root is -2, the factor is x plus 2, it's squared. Okay? And if the other zero is at 4, what's that factor? Well, if the other root is at +4, the factor is x minus 4. We also know that it has a y-intercept of 16. So let's put it in standard form. I have x plus 2 times x plus 2. I'm going to FOIL. What's x times x? And x times 2. And 2 times x. And 2 times 2. So this becomes x squared plus 4x plus 4. That's just what happens when I took the quadratic portion of this function, the multiplicity of 2. Now I have to multiply this by the x minus 4, my other factor. X minus 4. So x times x squared is x cubed. X times 4x is x times 4 is -4 times x squared is -4 times 4x is, and -4 times +4 is. Okay. So this becomes y, well, I don't want to use y yet. This becomes x cubed. These cancel out. These become -12 minus 12x minus 16. Okay. It says that it has a y-intercept of 16. What does that help me do to figure out what A is? Well, let's look at it. Y equals A times whatever this function is. When does the y-intercept happen? When what? When x is 0. Okay. So the y-intercept 16 happens when x is 0. So I have 0 cubed minus 12 times 0 minus 16. Well, if you simplify all of that, you get 16 equals negative 16a. So what is the value of a? It's negative 1. So what does that tell us about our function? It changes direction. So instead of as x approaches negative infinity, as x approaches negative infinity, y is going to approach positive infinity. It's going to change direction. I believe that to be true. Let's check. So the first thing that we have to do is simplify this because we know what a is. So y equals negative 1 times the quantity x cubed minus 12x minus 16. I need a minute and a half, and then we're done. So when I distribute my power, or my negative 1, negative 1x cubed. Negative 1 times negative 12 is negative 1 times negative 12. Positive 12x. Thank you. And negative 1 times negative 16. Oh, good. Now look at that. Now I see that I'm crossing the y-axis at the right spot. So let's plot our roots. I have a double root at negative 2. What happens when we have a double root? What dance move does a power of 2 make? A bounce. You're amazing. Makes a bounce. And what happens? So let's figure it out. So as x gets really small, y is actually going to go in the positive direction. So I have to do some kind of bounce here. And I have to cross at positive 16. So my function is going to look something like that.